We all know beaming from science fiction shows like Star Trek, and it turns out beaming is actually possible, namely with quantum states. And this is also the key technology for quantum communication networks. But the big problem, so far it is still largely dependent on chance, but that's over now. An Austrian research team achieved a spectacular success. Clixoom Science Fiction. Here you find exciting science videos 3 times a week. Subscribe to the channel so you won't miss a thing. Welcome.
1, 2, 3.
Beaming or teleportation, as it is also called, is by far the best means of transport you can imagine. In theory, there are 2 possibilities that could make teleportation possible. For this, a person would either have to be transferred into data only to be transformed into a physical mass again at the desired destination. Or the mass would have to be completely disassembled at the starting point and then reconstructed at the desired location. Even if this sounds totally unrealistic at first, in theory it is even compatible with the law of physics. Specifically, this is about the phenomenon of so-called quantum entanglement. Put simply, 2 particles share the same state, even though there is a great distance between them. Research teams worldwide have great hope in this technology because quantum communication networks based on it could make it possible in the future to transmit messages that are 100% securely encrypted, even over long distances. The process requires entangled pairs of photons. These come from nonlinear crystals in which a single high-energy photon is split in 2 entangled photons of lower energy, but chance still presented this field of research with a huge challenge. Until now, it alone decided when a suitable photon pair would be formed. Technological implementations have thus only been possible to a limited extent, if at all. However, a research team from Linz has now succeeded in circumventing chance in this process. In their experiment, the scientists managed to generate entangled photons at the push of a button. Specifically, they used tiny quantum dots embedded in semiconductor crystals. An aluminium gallium arsenide crystal was used for this purpose with a symmetrical hole etched into its surface. It was filled with pure gallium arsenide. The research team thus achieved a high degree of symmetry and purity of the quantum dots, which in the end probably also helped them to succeed. In their experiment, they excited the quantum dots by laser pulses and thus caused them to emit 2 entangled photons. One of the researchers involved, Markus Reindl, comments, "Basically, this works at the touch of a button. Each laser pulse generates a photon pair with a 90% probability, which we can then use for teleportation." Thus, quantum objects were actually generated on demand. According to the research team, a worldwide premiere. Even if there are still some weak points to be eliminated, some photons are swallowed by the system shortly after their generation, which is of course a disadvantage. In any case, the result gives great hope for technological use of quantum dots in the near future. This in turn would bring quantum communication a huge step forward. For teleportation as we know it from movies like Star Trek, this does not mean real progress. In order to implement this, and when it comes to just a tiny grain of dust, our technical possibilities are still far from mature. A few years ago, in 2013, a British research team roughly estimated that beaming a human being would not only take millions of years, but even the current state of technology does not really allow this person to be transferred from location A to location B in a practical way. Teleportation would simply require far too much data. The next big question would also be whether it would be possible to survive this process at all, and would the person still be the same after the teleportation? Despite these many unresolved aspects, there are some experts who are still optimistic. These include, for example, the US physicist Michio Kaku, who assumes that we humans will succeed in teleportation in the next century at the latest. What? Check out more on his view on teleportation by clicking on Michio Kaku, The Metaphysics of Teleportation. Here, stay tuned and see you soon.